Welcome back, everybody. Today we are talking about the properties of logarithms. And logarithms are the inverses of exponents. And so our properties of exponents also are very similar to our properties of logarithms. So for our product rule, if we recall what we do for exponents, if we have b to the x times b to the y, this means that we add our exponents, so it would be b to the x plus y. So similarly, with our product rule for logarithms, if they're being multiplied inside the logarithm, we can split this up to be log base a of n plus log base a of n. And the same is true for going in the opposite direction. If we have log base a of n plus log base a of n, we can write it as log base a of m times n. So if we want to express example 1 as a sum of logarithms, we would split this up to be log base 5 of 9 plus log base 5 of 27. And then if we want to express it as a single logarithm, one important thing that we have to be careful of is they have to have the same base. And so in this case, both of these logs have a base of 2, so then we can express this as one logarithm by writing it as log base 2 p cubed times q. And so then for the power rule of exponents, remember that if we had b to the x and then to the y, we multiply these, so this would be b to the x y. So similarly, if we have an exponent, we can bring this to the front as a multiplication, so this would be p times log base a of n. So for example 1, this would be negative 3 log base a of 11. This one we first need to write the fourth root as an exponent, so this would be log base a 7 to the 1/4 power. So this would be 1/4 log base a of 7. And then this would be 6 ln of x. In our quotient rule, if we had b to the x over b to the y, we would subtract our exponents, so x minus y. And similarly, if we have log base a of m divided by n, we can write this as log base a of m minus log base a of n. Remembering that the expression in the denominator is going to be what we are subtracting. So for example 4, if we want to write this as a difference of logs, this would be log base t of 8 minus log base t of w. Then again, if we want to express it as a single logarithm, for example 5, we need to be sure that it is the same base, and in this case our base is b. And so this would be log base b of 64 divided by 16. And if you can simplify it, we want to do that. And so in this case, this would be log base b of 4. And so here are some common errors that we want to look out for. And so if we are adding within a logarithm, we cannot express that as the sum of logarithms. And so just look at these common errors, be sure that you do not make these. And for example 6, we're going to go through example A, and then we'll do B and C in class, but go ahead and try those on your own. So with this one, we want to express the following in terms of sums and differences of logs. So we want to basically get everything outside of the log as much as possible. And so with this, we are going to be subtracting this z to the fourth power and then adding the x and y. So this will be log base a of x squared plus log base a of y squared minus log base a z to the fourth. And again, since x and y are in the numerator, we're adding both of those. And then since z to the fourth is in the denominator, we're subtracting that. And the last thing that we want to do is bring the exponent out in front. So this would be 2 log base a of x plus 2 log base a of y minus 4 log base a of z. And again, please pause this, try B and C on your own, and then we will go over these in class. And then to express this as a single logarithm, we want to do basically the opposite of what we just did. So the first thing that we want to do is bring our exponents, or bring the number in front to our exponents. So this would be log x base b x to the fifth power minus, there is no exponent for the y, so we're going to leave that as minus log base b of y, then plus log base b z to the 1/4 power. And so similar to what we did in the previous problem, if they have a positive x, if they're being added or have a positive number in front, this means that these two are going to be in our numerator. So it'll be log base b. If it helps to put parentheses around it, you can. Then x to the fifth, z to the 1/4. And then since log base b of y is negative, that means that that is going to be in our denominator. And then we will also do example 8 in class. For example 9, we want to split this up to be log base a of 2 and log base a of 3 to approximate this, because we don't know what a is, and so we can't type this into our calculator. But we can express 6 as a product of 2 and 3. So this would be the same as log base a of 2 times 3. And then we can use our product rule to say that this is log base a of 2 plus log base a of 3. And then we have these numbers for log base a of 2 and log base a of 3. So this would be 0.301 plus 0.477. And so then we would just add these together. So that way we would get that this is approximately 0.778. So for B and C, we want to express this in terms of 2 and 3. So go ahead and try to figure out how we can express B and C as a log base a of 2 and log base a of 3, and then we'll discuss those in class. And so one note, if we have log base a to the x, so if our base of our logarithm matches the base of an exponent within our log, this is just going to cancel out, so they're like inverses of each other. And remember that ln is log base e, and so, for example, in a, we have log base a to the 8th, so this is just going to be 8. And then ln and e are also inverses because ln is log base e, and so this would just be negative t. And For C, we have log of 10 to the 3k, remembering that if no base is written, it has a base of 10, so this would be 3k. And the same is true for if we have exponents to a log. So if we have a to the log base a of x, this would just be x. So then for example 11, part A, we have 4 to the log base 4 of k, so this is just going to cancel each other out and give us k. Again, e is the ln is the base, has the base of e, so this would be 5, and this one would be 17. So, if you have questions, please come with those in class, and we will see you guys on Monday.